little recap first. Vector combines magnitude and directions together. Here's a question. You need to determine the net displacement, and the paths involved are all diagonal. Both first and second trip involve a certain amount of trip towards east, so I'm going to decide east direction as positive. Similarly, if I look at north and south, the first trip involved towards north, but the second trip involves towards south, a bit longer, so I'm going to decide south as positive. Now I'm going to think about tip-to-tail diagram by connecting x components together. I'm going to do the same thing for the y component. As a last step, I'm going to connect initial position to the final position. Boom, that is a net vector, and you see the right angle triangle to find the net vector. X component require cosine of an angle, and since both directions share east direction, all you gotta do is add them up. When it comes to y component, it involves sine of an angle. Notice that the first trip involved north, the second trip involves south. So it is a bit of a subtraction. As a result, you get a net x component and a net y component, which will be used for the right angle triangle. Now, all we gotta do is use Pythagorean theorem to find the net vector. Don't forget about the direction. You can use any inverse trigonometry. Finally, you combine both the quantity and direction together as a final statement. If you know, you know.